Hey,
How you doing?
oh, good. So bird watching. That's how I wanted to give follow up on bird watching. I saw you had a tweet about that.
Okay, you're gonna out me.
Yeah, I am. Well, are you a known birder? Is this a recent hobby? What's going on here?
I like birds. I'm not obsessed in the way that some people are obsessed about birds. Um, I don't like. Yeah, I mean, for some people, it's Pokemon, basically. And if you know the story of Pokemon, is basically to try to encourage bird watching like activities in the general population through a game, which obviously did not do any of that kind of thing whatsoever. But now kids, have an encyclopedic knowledge of made up animals, which
Yeah.
maybe, I don't know. You can't quite iterate from there to them understanding evolution by natural selection and biology and so on. But anyway, I like birds. Birds are cool. The birds are good people. By the way, because I've said that we're going to get a bunch of snide comments about how birds aren't real, how it's all a
Oh,
conspiracy.
oh, I love
Maybe
that. That is just, I mean, thank you. I'm just glad the internet created that whole situation. I don't even fully understand it, and I'm just so happy. Um, Yeah, the bird. I brought up the birds mainly because I had a bird experience last night,
Okay.
and
What was your bird experience?
so there was this huge. I was outside in my backyard a couple weeks ago, and I was looking at this tree in the distance, and I noticed that the top was like sawed off, and I was wondering like how could the top of a tree fall off? So weird. And then all of a sudden, a gigantic owl lands on it, and it's basically the owl out of Winnie the Pooh, the wise old owl with the tufts and the ears, and it spins its head without moving its body as they do. And I ran inside to get the binoculars, stared at each other. I saw its yellow eyes. I was shook. I was like a spiritual experience, and I've been on the hunt for this owl ever since. Um,
Fantastic.
and last night I was setting up. Carly and I were setting up a mirror, and we heard the owl, and we went outside, and it was in our lawn, like in this tree. And I basically my thought was, I kind of get it. Like the Pokemon vibes, like collecting these things, allowing them to battle against each other, my bird versus your bird. I get the appeal.
You know what I thought was crazy living in San Francisco. As you know, I was in San Francisco for 10 years. Very interesting city, impossible to describe in a sentence or two, but
Yeah.
just one kind of observation. Everyone is doing something. Very few people are looking up and noticing that there are red-tailed hawks over the city, like over the middle of the city,
Yeah.
over skyscrapers. I mean, there are other raptors as well that like live in the skyscrapers, and there's just like all going on. Isn't it so cool to have hawks? Like, I'm also interested in smaller, not so like flashy birds, but
Yeah.
you've got actual hawks
No,
in
you can
above.
hear that. Like if your headphones are in, you're not going to hear like your AirPods, you're listening to something, you're not going to hear the screeches of those hawks. And
You're missing out.
I always think of the scene in Interstellar where they're all sad up there. Again, this is not really a spoiler, but Matthew McConaughey's character um, is like seemingly calm, and he's listening to just rain trickling, and just the sounds of the earth will allow us when we're like floating through space to just be grounded. And I had again a similar experience the other day running. I'm going on a run. I like to run a lot, and I'm going through this. The rains have finally stopped, so it's finally a nice sunny day, and I'm listening to a podcast about eliminating distractions from my life, and I just stopped. What is wrong with it? Why can I not be alone with my thoughts? And I turned it
Was
off.
my voice in your head as you were doing that?
Yeah, yeah.
As you were
So
recognizing?
yeah, it was like odds would not be happy. Um, yeah, so I think that kind of prompted why I wanted to chat with you today about this. So are we creating evil in the world by putting our voices out there, and how can we think about that? And also,
I wouldn't want to say
am I getting blippy? My video seems a little blippy.
you are blippy, yeah. Should we do
Yeah,
live debugging? What's going on?
yeah. Can you what's going on here?
I mean, if you notice it, it's not mine, but I'll try and trace route to a Zoom server.
Okay. I just did a little fast.com over here. I'm very things are happy. I'm 900 megabytes per second.
So let's both do this. We got to figure out which Zoom server we're on.
Okay. Yeah, I'm
Which
frozen again.
it looks like US02 web. Well, this is going to be the web server. I'm not sure how effective this will be, but assuming that the
Are you
servers are mostly
are you sending
co-located.
me a command I need to ping or something?
Uh, yeah, we'll do a trace route.
Okay.
Doing it from my end. I'll send it to yours.
Okay. Let's see chat.
We will not edit this out. Yeah, so just try it. I'm not sure if this is the same server that we're doing the communication via, but US02 web.zoom.us, and just trace route that.
Yeah.
You're on Mac OS, yeah.
Yeah.
Do you
Okay.
have MTR installed?
I don't have MTR.
I think you can brew install it. It's
Okay.
MTR. It stands for Matt's trace route. It's just like a
Oh, I think you were telling me about
way,
this. So brew
way better.
install MTR.
Yeah.
And Matt just has a better visualization.
Yeah, it's fantastic. I mean, it's more concurrent, and so you get updates faster, and it updates in place, and so you get aggregate statistics of well, it's an aggregation and a statistic of you get aggregate stats of like average, best, worst, standard deviation of ping to each hop along the way to your route, and the route is just assumed to be kind of static. So
Okay, I think I got it. So,
you got running.
oh, it says I need to, do I need to sudo this?
You may, yeah.
Okay. Oh, beautiful. All right. So I think I've reached it here, and I have
So
packet
what
loss.
you look? Are
Yeah,
you
what am
getting
I
any
looking at?
packet loss?
Yeah, I've got like 13, 12% packet loss at the eighth hop here, which is,
Oh,
yeah.
who is that eighth hop? Can
It
you?
doesn't give me a name. It's just a IP.
There's an IP address.
Yeah, but
Um.
there's 10 hops total, and it's like it's number 8.
Oh, interesting. Yeah, it's going to be close to a Zoom server then. Okay, let's.
Okay.
I guess this podcast is about how to live debug a Zoom call.
Yeah.
So, if you're seeing an IP address and not a host name, that
Yeah.
means that there's no reverse DNS record for that IP address.
Okay.
So, but we can still figure out more about it. So, one thing that we can do is run this with a flag that will show what autonomous system it's part of. Look, not
Okay.
that it's going to matter, because what are you going to do? Send an email to
No, no,
Zoom after this?
but what does autonomous system mean?
Okay, so uh, I guess it's a networking class.
Yeah.
So the internet is a network of networks. You know
Yeah.
that.
Yeah, I do.
Do you know the origin of how that started?
Well, you have the ARPANET, which was,
Yeah.
yeah, and then I think
So
there was something.
do you know what the ARPANET was? Like, you know that ARPA brought it together.
Yeah, I know
Well,
ARPA brought it together, and there were like 4 sites in California. I think that might have been the initial, maybe one in Harvard as well that was nearby. And they had these different, they hired BBN to sort of create these sort of like router machines that were like the first layer, but then it allowed you to have different hosts and different end hosts that had different operating systems and things like that.
yeah,
Yeah,
yeah. So you're getting a lot of it, including BBN.
yeah,
So there were networks already. People don't appreciate this. They think that Licklider, ARPA, they like invented the entire idea of networking. No, people were networking. The thing that they facilitated was internetworking,
yeah.
connecting one network to another. So like MIT, you buy this big mainframe, you pay 10 million bucks or something. Obviously, you don't want to just batch process the thing. Like, you don't want people to have to show up physically with punch cards, give it to an operator, and then like wait till the next day for an answer. That's not, you want to connect everyone with their teletypewriters. And so you start having this little network, and maybe you get a second machine and they communicate with one another, but also the, couple of dozen people who have teletypewriter access to the mainframes, right? That's their network. That's their local network.
Sorry, just to clarify, the network in this context is one mainframe and a bunch of dumb
That's
terminals.
how
Okay.
it starts, right?
Okay.
But then as you add more nodes, you're like, well, let's add a second mainframe. Why not? The mini computers start to show up. Let's add some mini computers. So you start to get a graph that forms of people who are connected to the individual nodes, and then do the hop to hop routing between them too.
Yep.
Um,
I'm still here if it looks frozen. Now I'm seeing loss at the first thing, my local network.
oh, that's you then.
Yeah. Okay. So
Uh,
that could be someone else in my household on the internet.
if you're getting packet loss, is it literally a router? Is it a private IP address like 192.168 or something?
It's unify.local domain. So I'm using Unify hardware.
Okay. Yeah, you like if you're getting packet loss there, I mean, uh I shouldn't encourage you all to just pattern match to the most likely thing, but the most likely thing, for some reason, you're overrunning a buffer,
Hmm.
and so packets that show up need to be dropped, but it doesn't really make sense unless you've got just a ton of throughput. Like the device should be provisioned well enough,
Yeah.
and so ultimately ends up being turn it off and on again. You got into a weird state. Some of the buffer's full of something that's not getting cleared or something like that.
Okay.
So you drop in packets at the end. But are you seeing both that and packet loss at hop 8?
Yeah. It's down to 4.3% at hop 8, and I'm at 1.9% at the first at my local.
Okay. Yeah, you got two problems, it sounds
I
like.
got two. I know what I'll do after this call, which is unplug and plug back in. Okay, but
Yeah.
yeah, internet.
Yeah, autonomous system. So
Yeah, so I know that eventually the ARPANET was able to connect these different networks. I remember there was something in Hawaii where there was another network going
yeah,
in
Aloha
Hawaii.
Net. Yeah.
Um,
Yeah,
yeah,
that's another great example. Like Aloha Net is very, very different to MIT's network, to what Stanford had, to what BBN was experimenting with, University of Utah, like all of these early, pioneers in networking. They were just networking their local communities, right? Their university communities, mostly so that people could get remote access to this expensive hardware.
yeah.
But it was a huge idea to say they should be connected with one another. That's Licklider's big vision. What Bob Taylor really helped implement. Happened to be funded by the U.S. military, but really wasn't about the kind of conspiracy theories that people. Well, I shouldn't characterize it like that. There was some interest from the military in funding packet switching, like the earlier basic technology that causes us to deviate from circuit switching, basic telephony. But and Licklider may have used the kind of defense angle to
To
get this
get budget.
funded.
Well, is
Yeah.
the conspiracy theory being this is the network that can
Oh
withstand
yeah.
nuclear war? Yeah,
Yeah. The
yeah,
internet was invented in order to be able to route around nuclear
yeah.
destruction or whatever. That's not no. The thing that we call the internet is Licklider interconnecting existing local networks, because he believed in literally an intergalactic super network. Isn't that fantastic?
Yeah, yeah.
To share knowledge, like to have knowledge that's locked up in one institution be shared with another. Like it is just the vision of the internet, not some defense strategy. But
Did
yeah,
you
there was.
slight distraction, but I can't remember exactly the news article, but it was someone involved it was either Ethernet person. Is it Metcalf, the Ethernet
Metcalf,
person?
yeah,
Yeah.
Bob Metcalf.
I think there was some article a couple years back where they were talking about what actually would intergalactic TCP IP look like. And they were saying the routers might have to have some sort of state because there's experiencing like some sort of like disconnect. So he was working on TCP IP for communicating with Mars, communicating with like Europa satellites and things like that. Did you see that article?
Was it Metcalf?
I don't know. I'm just imagining it was someone like that. It might have been someone else.
Yeah, I mean, yeah, it's an interesting thing to consider. We do have satellite internet. I mean, I'm just about to get Starlink.
Okay,
Um,
good. Yeah.
yeah.
I'll look that up and I'll find it for next time. But
Well, we still got
how
to
does any
figure
of this
out.
solve
Don't
my problem?
look. Don't get Starlink if the problem is at Zoom's end. So we still need to figure out which autonomous system this IP address is part of,
Yep.
causing you to drop packets. But what is an autonomous system? We're getting to that. The autonomous system is a legacy of this origin of the internet, where the whole point was to say we're providing a protocol for internetworking, but once it gets to your network, you control what's called the interior routing.
Hmm.
So these days we use a protocol called BGP, Border Gateway Protocol, you may have heard of,
Okay, I
that
recall that.
defines. So BGP, it's one of those like miraculous that it works, honestly shocking that it works. Piece of vital infrastructure implemented both in hardware and software, that is just like underlies the internet. You know, the internet wouldn't work without it, or an equivalent. It is the protocol that defines how two autonomous systems share routes. So let's say that you spin up as an autonomous system, you're a new ISP, new data center, just a large organization, and you want to interconnect with other people. You are participating in BGP. You have an autonomous system number. You have routes that you control yourself, like your own IP addresses, and you're advertising this to your peers. Peer is a technical term in this case, which means someone with whom you exchange routes directly, and you have a physical link, right? You might be in an exchange point, or you just have a physical connection between one of your routers and one of their routers.
Okay.
So the BGP defines how you advertise yourself to the rest of the world. And did you catch wind of the Facebook outage? Is it last year now?
Yeah, I'm not sure.
There was like a major Facebook outage. Like Facebook.com was out for something like a day, and it was just fundamental to the point where Facebook employees could not get access to Facebook HQ because their swipe card authentication was over the public internet to Facebook servers, which were inaccessible due to, I mean,
how can we fix Slack if Slack is down? Or how do we?
Yeah, it's like they literally could not get into the building because they couldn't reach their servers over the public internet. So they had to like physically go to their data centers and then like convince the security people that they should be allowed in. And I just imagine them being like, look, Facebook.com, it's down. I'm Facebook.com. I need to be able to get in here. Yeah. I've only ever SSH into these machines, but I need to physically walk up to one now because I can't SSH because of a really fundamental issue with BGP. With BGP.
So what was their BGP problem?
I don't know if I can tell you because it's just too, and I shouldn't laugh because like, you know, it's like, it's kind of catastrophic for them to be down for that long. But they basically, due to a reason that they have not specified, it could be like human operator error or like a semi-automated system generating configuration that was not properly QA'd. But basically, they advertised to their peers that they no longer existed. So they using BGP, they send out a notice effectively saying Facebook.com, this IP address range does not exist. So that means that the peers are dropping that traffic and not forwarding it on to Facebook. It's just like, there's nothing there. There's nothing behind that IP address. So like, why would I send you that packet? Why would I forward that packet? And then those peers also propagate that information to the rest of the internet. So until the new routing information gets repropagated, once they figure out what's going on, advertise that and get that propagated again, everyone is just dropping packets that are addressed to Facebook.
How do you reconnect to, like, how can you reconfirm that you're legit again? Do you have to change your BGP range, or do you have to like request packets come through and have those be successful? How are they able to work their way out of that?
I mean, basically, did I say it's surprising that BGP works? There's a level of trust that you have. Yeah. I mean, there's also means of verification, but more or less, you're sending these routes through a direct physical connection that you have to your peers, and they accept them. You know, and you know, it's reasonably secure there because you had to go through some process to establish the physical connection. Yeah. Someone else can't really come and like impersonate you in that physical context. But yeah, basically they just need to say, whoops, no, actually we are here. Please do forward traffic over this hop and you know, over this link to us for this IP address range, and then that gets propagated.
Got it. Are you? This reminds me of something from where wizards stay up late. The Christmas Day bug during the ARPANET days, where apparently Harvard started advertising that they were 0 hops away from any destination, and then everything just started flooding to them. And this was on Christmas Day, and it was like overwhelming everything. So all messages were like, oh, this Harvard node is the closest stop no matter where anything was going. And they apparently had to like physically cut the link from the system.
It happens. It happens all the time, to the point where like this outage was going on, and I was on Twitter, just because it's an outage, it's so exciting. I got to see what's going on. That's my excuse for being on Twitter. And sorry, I'm trying to multitask and also bring up an article here while I talk. But people were like, the DNS servers are down. It's DNS. It's always DNS. And I'm like, the DNS servers are down, but so is every other server in this IP address range. Like you cannot ping the IP address that the DNS server would have given you. It's not about DNS. It may be about BGP. And it's getting to the point where I'm like, is it always BGP? The meme, like it's always DNS. It's like, it's not. Anyway, for something at this scale, it's like you got to be suspicious that it's BGP. But the incident that I didn't know that that story, but what you describe, it happens all the time, and I've got a favorite one that I'll bring up in a second. I just got to remove all the private stuff from my screen before I share it.
We're getting a screen share.
Let's see. All right, let's see. Now I got to do Zoom. I got to carefully share this screen and not the other one. Desktop 2. Okay.
BGP.
This is just a great title after what we've discussed.
Yeah. It's not our fault.
Oh, it's not. It's definitely not Cloudflare's fault. Like for sure here, it's absolutely not Cloudflare's fault. Cloudflare just has a kind of bird's eye view on these things, where it's like, oh, if the internet's down, we're going to notice, and maybe we can help fix it even.
Yeah.
At least we can help figure out what's going on. This article is fantastic. Like everyone needs to read this if you work with the internet or are just curious about how the internet works. Firstly, it was written during the incident, so impressive to them that they could get it out. But they explain exactly what's going on. So with BGP, you advertise these routes. There's this idea of an optimizer where you're saying, hey, like take this route. I can explain the subnet notation. Or do you recognize this subnet notation? Do you know what the /20 means?
No.
Okay, so this is saying, when I say advertise route, what I'm saying is, look at these 32 bits. Remember, an IPv4 address is just a super dorky way of expressing 32 bits.
Yep.
Each of these is 1 byte, dot decimal, just the worst possible notation. Anyway, a separate podcast on that.
Okay.
So take these 32 bits expressed as dot decimal, consider the first 20 of them, the high order 20 of them. So starting from the left, that's why the zeros here are kind of irrelevant. At least the last zero here is totally relevant. Starting from the left, consider the first 20 bits. If your IP address has its high order 20 bits matching the high order 20 bits of this, then it is part of the subnet. It is a way of grouping together IP addresses hierarchically based on matching the high order bits.
Okay. And so do you have to agree with your peers on the number of bits or the range? Like, what is the agreement?
This is just a way of talking about a set of IP addresses, right? Because you don't want to talk about every single IPv4 address as an individual thing and say, hey, send this to Facebook and also send this to Facebook, because then you get a table of 4 billion things, right? 2 to 32.
Yeah.
You want to talk about a range. And so IP addresses have an inherent structure, left to right, hierarchical, where if you have more matching at the high order bits, that means that it is closer to your destination.
Okay.
Yeah, this is the fundamental way that IP does routing. First, exterior routing that we're talking about with BGP, and then we can talk about interior routing too if you're interested.
Okay. Yeah.
Basically, what the router stores is this subnet mapped to a physical interface where it's like, hey, if it matches this rule, then forward it over this physical link. If it doesn't, forward it maybe over this physical link based on matching a /10, right? Like maybe by matching the first 8 bits or 10 bits or something, you're going to say, well, this is towards the East Coast rather than the West Coast. I don't know more than that. By matching the first 2 bytes, you're like, well, this is Northern versus Southern California. If the better the match, the closer you're going to be able to forward it. And so
So
as you get closer,
does it try to get the largest match first?
yeah, it's
Okay.
called largest prefix match. That's the name of the
Okay.
algorithm, largest prefix
Got it.
match. So routers are implemented to search for effectively the longest match that you have against the IP address, the destination
Yep.
IP address, and that's how it decides. Yeah, it's just like if you were to ask for directions, you're driving from San Francisco to New York, and you're like, "Hey, how do I get to this very specific place in New York,
Mhm.
like 25 3rd Street or whatever?" And someone's like, "Well, I know exactly that address, and here's the highway you should take as your first step." You're
Mhm.
going to trust them more and take that highway. If someone's like, I don't know where that is, but to get to the East Coast, I think you take Highway 1.
Yeah.
That is like, it's better than nothing, but you want the person with the more specific information. And the closer you get to New York, the better directions you're going to get for the specific address because it's going to be a greater match of the address overall.
Got it.
Reasonable analogy?
Yeah, yeah, for sure.
Okay. So if you have a /20 address, you could optimize by saying, hey, actually consider this as 2/21 addresses, split it into two. And now, implicit in this is that you're associating these with different interfaces now to be like, hey, this is a general address. I know more about it. I know more detail. And so the routing should be different if it matches X versus Y.
Okay.
Any questions about that?
So you're adding another bit here. So this is it called knock BGP optimizer? It's figuring out how to add another bit, so now it'll theoretically be more precise.
Well, I mean, don't think about it as adding another bit. Think of it as taking this set of IP addresses
Yeah.
and dividing it into two disjoint sets of IP addresses.
Okay. Okay, I see what you're saying.
Right? This is like adding another bit of significance to here. It's saying, well, like if you extend our analogy, before this was saying Manhattan, and now this is saying, well, like Manhattan north of 40th, and this
Yeah.
is Manhattan south of 40th.
Yeah, yeah, yeah.
And by having a more specific address, like range that you're talking about, now this takes priority in the longest prefix match algorithm.
Okay.
Right? So a router that has this route and has these routes will match against these with preference.
Okay. I'm following.
That's
That
why
makes
it's
sense.
optimization.
Yeah.
Okay. If you get it right, this is a reasonable idea, I guess. If you get it wrong, what happens is that everyone who is trying to go to anywhere ends up driving down this one narrow street. And that's what happened. Right. So this, I mean, read the article, but basically this middle of nowhere ISP, no offense to people who live in northern Pennsylvania, but this middle of nowhere ISP is advertising itself as a route for a very large chunk of traffic on the internet.
Yeah.
Due to a bug.
Yeah.
With their optimizer or how they configured it or whatever. And organizations like very large autonomous systems like Verizon are not correctly verifying that because, for decades, nobody bothered to do that because the internet was a niche thing. And over time, we've developed protocols for verification of this kind of thing, but not everyone's doing it, including Verizon.
Yeah.
Those who don't know, Verizon is a very large ISP in the US. So anyway, I mean, of course, there's an instant pylon. Like, imagine just you reroute a tenth of the traffic. Like, imagine a tenth of the car traffic in the US goes down one street. Just like instant pylon.
Yeah.
So anyway, internet goes down. In effect, the internet goes down. Like I experienced this. There were major websites that you just couldn't access. And
can you, as someone facing this, is there any way to exclude certain ranges from when you're sending your requests or things like is there's just no way to say I want to avoid this middle of the route?
No, I mean it's supposed to be transparent. That is to say, your computer, ultimately your operating system is placing a destination IP address in this packet, and it's going out over the network, and then it's up to the routers from there to have correct forwarding tables.
Yep.
And you don't really have control over that. Like all you get to pick is the destination IP address, other than using something like a VPN. But ultimately, it's not going to solve a problem
So
like this,
again,
right?
is this a unplug, fix, and plug back in situation to fix?
For this,
Yeah.
no, like they need to put the correct routes in there. And so, again, fantastic article because it's got like, how did we fix this? Well, we called up the autonomous systems that we found that were accepting the incorrect routes, including Verizon. And it's just like,
Oh my goodness.
and yeah, it's like at time Cloudflare is so good. They published this article by the time Verizon had picked up the phone about this.
Oh
Other
boy.
ISPs fixed it, and they're like, "What? Really? Internet down? I'll deal with it tomorrow."
Has Verizon published an article about this ever? Have
Oh,
they?
would they publish an
No,
article about this?
no.
I
Maybe
doubt it.
they're being publicly goaded here. No, so I don't understand. Couldn't they just, if they contacted these autonomous systems, if they just get unplugged, won't the traffic learn to avoid them? So I'm just curious in practice, did they have to hot fix the routes? Did they?
Oh,
Yeah,
yeah. I'm not sure
yeah,
about like how the persistence of routes and what they do to like recover from failure if there's like a hot standby but the problem is you'd have to relearn all the routes.
yeah.
So I don't think that it would be a viable, preferable way to do it. But yeah, I don't actually know the detail of persistence. I'd love someone if someone figured that out to just let me know.
Okay,
Um,
cool.
so I've not worked in this part of the network. But by the way, this that was like a summary article, and then a little later they have a detailed. Here you go, deep dive. How good is the Cloudflare blog? I feel like I want to design a course that's just like let's understand a whole bunch of stuff in the Cloudflare blog.
Yeah, and didn't
Um,
you recently shared someone's I forget whose website, which is just or repo, which is just a list of the best postmortems, which it
yeah,
says
Dan
that could
Liu.
be Dan
Yeah,
Liu.
yeah,
That should be a
yeah,
course too.
yeah. Dan Liu's. I mean, definitely there should be a postmortem course. I mean, my distributed systems course kind of ends up being a postmortem course at times. I
Yeah,
do in the first class bring up that list of postmortems,
yeah.
and there are some key ones there that I emphasize as a way to really scare people into not having distributed systems unless they really have to.
Right, right, right.
But yeah, so here's the detailed article, and you will learn a lot about BGP if
Wow.
you
Okay.
read it in a kind of students with a student's mentality of like, let me understand exactly why this works. And then Ben Eder, of course, Ben Eder, the 8-bit computer guy on YouTube.
Oh, of course. Yeah.
Yeah, so he was a network engineer before he went to Khan Academy, and he has network engineering videos that are quite good as well.
Yeah. Yeah.
Um, and he did one after the Facebook outage that I mentioned that explains a lot about both DNS and BGP. And he actually, the kind of stuff that we're talking about, he demonstrates live. I don't know how he did this, but he's like, oh, yeah, a buddy gave me access to a router, I guess like someone who knew from when he was a network engineer.
Uh-huh.
And so he like SSHs into a real router and shows you the forwarding tables
Wow.
uh,
Okay.
as his way to explain this. The longest prefix match and all the things that we've discussed, but through just in order to demonstrate why Facebook went down, gives you that first principles kind of view. Very, very, very good way to understand that, in my opinion.
Yeah, I'm
Uh,
sad there hasn't been an eater video in a while. I'm
oh,
a big
has he not
fan.
published in a while?
There
Maybe
was
he's
he
working.
was doing a series around making your own VGA card, I think, so as a sort of follow-on to his 8-bit computer. But yeah, we should get him on the show.
Oh yeah, I'd love to have him. Yeah, as an educator as well as
Yeah.
just great projects.
Okay. So
Anyway,
so
so you're
going
originally
back to
asking what's an
my
autonomous system?
yeah. So autonomous system, can I play it back to you?
Yeah, please.
It is a group of it's kind of like an ISP. It is a sort of network that has decided to attach itself to the internet for some reason, whether it's an ISP or some sort of lab or something like that. And the internet at its outer edges, prior to like the hosts. This is the autonomous group are the things that have to adhere to the physical link protocol of the internet. Am I getting it right or no?
I wouldn't describe it that way, but everything
Okay.
else that you said, yeah.
Okay.
Yeah. So um, we've got a lot of machines on the internet. You want to think of them as logically grouped into autonomous systems that
Okay.
are autonomously administered by entities, very often ISPs, as you mentioned, but also like Facebook is an AS, and anyone who's running a data center,
Okay.
large companies, they're managing these clusters of machines behind a set of IP addresses.
Yeah.
Now, the nodes at the edges of this autonomous system that physically peer with other ASs, they are using BGP to advertise the routes. And so they have that physical link to their peers, right? The Google data center is connected. Actually, why don't we do a little bit of this live as we go as well?
Okay.
Do you want to run MTR again, but get the AS number? I forget an MTR. If you look at man and then /AS, it's either, yeah, I'll do it at the same
Well,
time.
my packet loss is gone now, if that helps.
Damn it. Well, if we could still look at hop 8, if hop 8's still the same.
It looks the same. Yeah.
Yeah, it's slash sorry, it's minus Z, the flag in
Okay.
MTR. It's
Yeah.
A in the
Oh, I see.
DSD.
Okay. Yeah. Hop 8. So do you want me to read that to you?
Are you
Paste it.
running it with the Z flag?
Yeah.
The Z flag?
I have this AS number.
Okay. Do you want to share your screen and just Google the AS number?
Yeah. Now I have to close 10,000 things. 1 sec.
Don't show the trace route if you don't want people to know your general location.
You got it. Okay. Setting things up. I hopefully it'll let me, because I haven't shared my screen in Zoom yet. All right.
Or you can give me the AS number and I'll look at it.
Yeah, hold on. I want to figure this out. We're getting close.
Honestly, screen share is probably better than your video anyway if you got packet loss, because it compresses better.
Okay, let's see. Wait, how do I do? I'm so used to Google Hangouts right now. Do I do
Really? There's
more?
a huge green button, share screen.
Oh, huge green button. Okay, there we go. And
This is where people are like, can I just edit the podcast just a little bit?
No, we don't edit. I'm sorry. Okay.
Look, if we edited this, we would only do half as many.
Yeah.
Maybe if that.
Okay. I'm
Got
sharing.
it. All right.
You see this? Now I'm gonna,
Yes.
I think I'm just sharing that tab. So I grab this AS number.
We do see your bookmarks, so
I know I couldn't figure out how to get rid of those, but they're innocuous. You can see my writing tracker. Okay. Here we go.
Fantastic. Yeah. I should have been able to recognize that because I've had issues with Comcast as well. Okay, so the ipinfo.io should be fine. And then that one. The first one is probably fine too, but yeah. This is just like an aggregation of publicly available information related to the AS.
Okay, so I just want to go, I'm kind of glancing back at the trace route here. It is the same AS number from hop 2 all the way to hop 8.
Comcast is big.
Yeah.
Yeah. So I don't know if Comcast is your ISP, if it's hop 2.
Yeah, I have Xfinity. Yeah.
Xfinity, yeah. So Xfinity, those who don't know, is the consumer brand of Comcast.
Yeah.
So that's why it's hop 2, because it's your ISP. That's what's going to be the hop after your home router.
Yep.
But then they're responsible for getting your traffic ultimately to Zoom, but they may be a peer of Zoom, and actually we can probably figure that out if we want to, if we had time. So they may be the last hop before Zoom. A more traditional kind of setup, if you're not using an ISP the size of Comcast, is that you might have a regional ISP. Like in San Francisco, there's one called Monkey Brains.
Yeah.
It's tiny. Maybe they're also in Portland or something. Like I've got no idea, but I'm just like guessing. It's a very niche ISP.
Yep.
That's your retail, like small local ISP. But like they would then need to get traffic further out into the internet, right? So maybe hops 2, 3, 4 are Monkey Brains, and then 5 is going to be what's often called a regional ISP, traditionally something like Comcast, and that's maybe going to get it interstate or across the country or something. But then even Comcast is not what's called a tier one ISP.
Yeah, for some reason I thought maybe that Comcast would sort of stop maybe in California, and then it would enter this sort of like information superhighway that is generic, and maybe that's the tier one. So I'm probably thinking about that wrong.
Yeah, Comcast is not technically part of the backbone, which is
Okay.
the tier ones.
Yeah.
But it is so massive. It's like it's kind of close enough. So Comcast can't guarantee that it can get your traffic to literally anywhere. So if if we were to run MTR again to yahoo.co.jp or something,
Yeah.
you're gonna see non-Comcast hops after it goes over the Pacific.
Right.
So even just like the penultimate hop before the Pacific, you're going to see, like, before you see that big latency jump, you're going to see that it's not Comcast. I believe, at least for you, my guess from California. But uh yeah, so they're not technically a tier one. The tier ones, they do what's called settlement free peering, which is basically they peer the same kind of peering relationship that we've described, but just like you would pay Monkey Brains and Monkey Brains pays Comcast, or like specifically in your case, you pay Xfinity. If Comcast needs to use a tier one like AT&T, let's say, to get the packet further, they pay AT&T for that,
Yeah.
right? It's like wholesale internet. Um, it's like they're the retailers to you of internet service, but they also need to pay other people if the traffic is going to be conveyed, right?
Would a tier one just their business model is never to go direct to consumer? They're really their customer is just the ISPs. Okay.
Well, kind of. I mean, AT&T obviously has a consumer business as well,
Yeah.
but what they're doing in this case is entirely detached from their consumer business. Comcast is interesting because it very much has a retail offering in
Yeah.
Xfinity. There's Comcast Business, which is like a retail to business offering as well. But then they play the role of a regional ISP and closer tier one as well, by providing more wholesale level service. They're just in more business. But
Yeah.
most of the tier ones, they just kind of stick to that as a kind of wholesale business. But yeah, to be a tier one, in effect, you're getting into agreements with the other tier ones to say it's free traffic. We're not going to keep track. You give stuff to me, I give stuff back.
Yeah.
Request has a response. It kind of evens out.
Yep.
So that's why it's settlement free. Anyway, just to give you a kind of idea of the structure of the internet, after you learn about autonomous systems, it's like, well, who runs these? Why? Who pays whom? Like, why does everyone actually carry the traffic? It's
Yeah.
ultimately these commercial arrangements that you don't see, and then physical arrangements of actually connecting, and then whole businesses of like, let's make a building where everyone can get together and do their peering like physically, which has its own.
I'm still not fully understanding tier one because again, tier one seems more fundamental. Is tier one quote unquote everywhere, or tier one isn't even everywhere? It just happens to be gluing certain things together.
The super highway or backbone kind of analogies are reasonable. It's like these are the really high throughput links that a lot of people are going to send a large amount of traffic over. They're
Yeah.
not the smaller like arterial roads.
Okay.
They're not the like local roads that end in cul-de-sacs. That's
Okay.
all
And
the
so
retail
and
ISPs.
so Comcast would rather like it's made the play that they're going to get big enough that they don't want to have to pay the tier one. So they're just growing their
Exactly.
network and they sort of stay internally. Okay.
Exactly. Every time they pay the tier ones, they're like, oh, can't we just have this link ourselves? Obviously, that's very expensive infrastructure to put into place, particularly the like oceanic cables.
Yeah.
So there's going to be a limit to how much they want to invest. But if they can avoid paying tier ones,
I'm
you don't
shocked
need to get
Comcast
into
isn't.
selling them.
Why is Comcast not charging me by the distance of the IP I'm requesting?
Oh yeah, I mean that's just like how the business ended up.
Okay.
You gotta make it friendly for consumers and have
Okay.
like a unlimited. We've kind of equilibrated around an unlimited plan for a certain amount
I mean,
per
I thank
month.
God they have, but I feel like if they had the choice, they would have definitely penalized you for.
But it's like, what are you gonna do as a consumer? Be like, well, I'm gonna use caching more. I'm gonna use a local cache. Yeah,
Yeah.
it's hard for the business to
Okay.
reflect the physical reality of how the packets are moving for sure.
Okay. Now
Okay,
I'm
all
on.
this is to say you can complain to Comcast You will get mixed success if you're on Xfinity. But I did this with Comcast Business,
Yeah.
where you can call them up, say, hey, can I speak to someone? I mean, obviously, you got to escalate to someone who you can talk to about your trace route.
Press zero at least 3 times.
Yeah. But eventually you can be like, hey, man, I did the trace route and here's the packet loss that I'm getting. And, I can give you some logs. You mind looking into it? And there's someone there, particularly with Comcast Business, they do respond. There's someone there who's
Okay.
like, yeah, you have in fact identified that we have an issue. I have
Nice.
to admit it, and we will maybe fix it. So
Nice.
anyway, you
Okay.
pick it out that it's Comcast.
And then for that solves that. For my local thing, it seems like after we hang up, I just gotta unplug and hope for the best.
Yeah, that's probably stayed on your router.
Yeah.
The Comcast thing is tricky though, because like you're saying, do I get Starlink? And Starlink would disintermediate Comcast for a lot of this, maybe for the entire thing. Depends on what kind of peering relationship Starlink has at its kind of terrestrial nodes. But it could be that you end up back at Comcast because they're kind of ubiquitous. And this particular hop is so close to the Zoom server that you are kind of beholden to
Okay.
them.
I just did the next one too. So right after this is hop 9. So
Yeah.
Cloudflare.
Oh yeah. Okay. This is where it's not actually matching our experience of being on the Zoom call here, even though you did manage to pick up the same packet loss or some packet loss. If
Yeah.
it's getting to Cloudflare, what's happening is that the Zoom website must be using Cloudflare as a CDN.
Yeah.
And so Comcast is peering with Cloudflare. And this website, if not this website, then another BGP aggregator. If you scroll down, it should show the main peers, and you may actually be able to see Cloudflare peering with. Yeah, can you scroll down more?
Peers.
No, peers. There you go. Yeah, so we should see Comcast on this list of peers. I mean, this is if anyone is going to peer with everybody, it's Cloudflare. So this is a very long list.
Yeah.
But well, I shouldn't say that. Obviously, many ISPs want to peer very extensively as well. It's not typical to see over 1,000 peers. This is like 1,000 contracts that they enter into.
Wow.
To physically link with these entities.
So
But yeah,
that
if you
means
were
that
to
they're
show,
physically linked, not linked through some other hop.
yes,
Okay.
it does mean that they have a direct physical connection. They may outsource the management of that to another company.
Yeah.
And there are many that run these internet exchange points. But yeah, this, by the way, this is all of the peers. If you go back into your Google search and to go to that Hurricane website, I think that one, yeah, do that one. I think that ranks by top peers. That may be a bit more illustrative.
Yeah, it's loading or validating or something. Okay. So this is for Cloudflare.
Yeah, this is Cloudflare. Okay, that's a lot of peers. It's interesting to see the peer count as well.
Oh, wow. So can you find out, can you surmise where this is based on the number of peers that is there?
Can
Is
I
there
figure out
yeah,
physically where it
physically?
is?
Yeah, no, right?
No, I mean, not
Yeah.
by the number of peers.
Yeah.
I mean, you can infer it's probably in the US because that's where this
Yeah.
this kind of thing is most aggressively done. But
Okay, I want to see. I want to look at the last one here.
yeah, scroll up a little bit more. So the AS that I see there is why is it only showing? Oh yeah, I guess because there's such a long tail for Cloudflare, it's showing like it's showing one top one and then others just based on bad data viz. But for a more typical AS, that visualization will show like top 10 or 20 or something, which is often interesting. Do you have the AS for the next hop after this?
Yeah, yeah, this is the final one. I'll plug it in here at the top.
It could also be one of Cloudflare's.
It is.
Yeah, Cloudflare London. That's interesting.
Oh, wow.
Well, it may not be that interesting. It's just like the entity with which the AS is associated.
Okay.
The AS number is associated. It may not be a big deal. You know, companies accumulate these through acquisitions and stuff.
Okay. All right. So every hop in this thing is an autonomous system.
Is every hop in your trace route an autonomous system? Is that what you're asking?
Yeah. So, well, I guess so these are hops within an autonomous system. So that's that
Yes.
block 2 to 8 is all within that one autonomous
That's
system.
all Comcast.
Okay.
Yeah, yeah, yeah.
Okay.
So from the perspective of like how does that work? Why is that happening? That Comcast determines how to do its interior routing.
Yeah.
And by the way, they don't get it right all the time, and you can't call them up and say I did a trace route from here, from Northern California to Southern California, and went through Texas. I
Yeah.
have proof, fix this, and sometimes they will fix it.
Right.
Anyway,
And because it does
so
seem like they're giving me a little bit of detail within Comcast. I can see, okay, this one is like somewhere else in California. So they're
yeah,
like,
you see the reverse DNS. The
yeah,
reverse DNS is not foolproof.
yeah,
Basically, they just have a DNS record in there in the DNS system
yeah,
that has a kind of flipped structure that allows them to specify a host name for the IP
cool.
address. So you can't like 100% rely on it, but you can typically infer what those interior hops are. But the thing to point out is that that does not use BGP. So the logic
Yeah,
of within from 2 to 8 in your case, how it's doing that routing is up to Comcast. If they wanted to manually configure all the routers, they could. Obviously, that would be lunacy. We do have automated systems. Basically, do you remember like Dijkstra's algorithm from
yeah,
algorithms class?
yeah, yeah.
It's basically like Dijkstra, Bellman 4. This is one of the big hits of algorithms. You're like, if you ever get to teach algorithms,
Mhm.
you're waiting for the weighted graph traversal class where you're like, guys, we managed to get it into the internet. Well,
Yeah.
it's not the internet, it's just interior routing in an autonomous system. But basically, these algorithms, they're open source ones. OSPF is a common one you can look into if
Okay.
you're curious. But it's basically let's run Bellman Ford or Dijkstra or like some variant of
Nice.
this weighted graph traversal to see what's the shortest path between
Yeah.
any two nodes in the
Yeah.
system.
No,
You
it's nice
can't
to
do that at the level of the internet because there are too many permutations, but or too many like pairs, but you can do that internally.
it's nice to know the algorithm stuff pays off.
Just that one though. Just that one.
Sweet.
It's
Okay.
like you teach
Well,
11 out of 12 classes where you're like really
yeah,
struggling
you're
hard to
not going to
find
use
your
it. Yeah, I sure you're going to use it, but this paid off. Okay. Wow. Well, would there have been one other question? Would there have been anything from this trace route where you and I could have said, you know what, do this, and we fixed it? Like, how actionable was this investigation outside of, okay, I'm going to call
okay.
up customer support and they're going to maybe get back to me in a year?
In this kind of situation where it's
Yeah.
like I'm having an issue, I'm dropping packets on a Zoom call,
Yeah.
the best you're really able to do is better diagnose the problem. Is it Zoom? Is it my ISP? Is it someone else's ISP? Like, is it something along the way? Is it my local network? You figure that out very quickly with traceroute.
Yeah.
Typically. And so, the difference between turning off your router, switching from Zoom to Google Hangouts, changing your ISP, those are very
Right.
substantially different
Okay.
things. But like, what are you going to do after that other than call and complain and maybe change ISPs? Not so much. The thing is, if you are running like a networked application in a data center, you're participating in this. Sure, you're
Yeah.
outsourcing some of that to Amazon, but like you're part of Amazon's autonomous system, you know.
Yeah.
Well, I guess it still comes down to a customer service thing, but no, I mean it may get to the point where you're doing your own routing within AWS, you're
Yeah.
configuring that yourself, and you've gotten something wrong, and that's going to show up on traceroute.
Yeah.
Yeah. So in the final hops, that's what you might do with traceroute. Yeah,
What's
or
that?
you have a fancy local network, I guess, but more likely it's from the perspective of you and I as software engineers who write networked applications, we're probably going to do some amount of networking, at least via configuration in our data center. That's going to be more than one hop a lot of the time, and you're going to be able to see that in traceroute.
It would be sweet to add to traceroute the hops between the different access points on your network. Like,
Oh
okay,
yeah, but that's just not an IP thing. Like it's not IP
yeah,
addressed. Yeah.
yeah,
So you're talking about like you got a switch,
yeah.
a link layer switch, like an Ethernet
I got a
switch.
cable with a switch, and maybe I'm like, there's an wireless access attached to the switch. Yeah,
Yeah, it's just like it just works in such a different way. Like it seems like a router switch, like it's basically the same thing, right? You plug in cables, it
yeah,
forwards the data based on rules.
yeah,
But like a switch doesn't have an IP address. it doesn't even have a MAC address. It's not an addressable entity. It is just a thing that receives data and then forwards it on based on logic that is entirely different to the prefix free as the longest prefix match algorithm of IP.
Yeah.
And so, yeah, it's like very commonly confused switch and router, particularly because people will sell like a thing that acts both as a switch and a router as one unit. But conceptually, yeah, it would be cool, but it would be very hard again because you'd have to infer they're not addressable things.
Yeah. Well,
what were we going to talk about, Charlie? Birds?
Why this podcast is birds. This is a new birding show that we put out.
Why you should not listen to podcasts. I mean, this ended up not being a podcast, really, I guess.
No, it didn't. I certainly wouldn't want to watch this episode given how frozen I am halfway through it. But who knows? Maybe someone will enjoy it.
Yeah, what were we saying? Yeah, don't listen to podcasts.
Don't listen to
not on your run, at least. No, you got to appreciate where you are, not to give away your location, but red-tailed hawks and
owls. I'm going on owl watch again tonight. I will report back. Maybe I'll get a photo.
Do you know what kind of owl it is? Just for my own curiosity.
It is great horned owl.
Oh wow, cool.
Which I looked, that is very widely distributed in North America, but I've certainly never seen one before.
Yeah, I mean you gotta be paying attention. That's what we're talking about. The red-tailed eagles are also.
Yeah, I remember seeing those or hearing them in Alamo Square in SF. Just so cool.
Fantastic.
Okay,
go watch some birds, everybody.
All right,
and capture packets. Do some trace routes.
Yeah. Later.
Thanks, man.
See ya.
Take care.